channel on chemistry. Now today we'll be looking at chromatography. Now chromatography are the basic principles, how the separation is being carried out, and the basic concepts in chromatography. Okay, now chromatography was discovered a long time ago by Michael Seward, and the technique is actually a technique used to separate, isolate, and purify organic compounds, basically compounds. To purify, isolate compounds, you can use chromatography to identify compounds after a given reaction or experiment. You can use chromatography. Now, what is chromatography? Now, chromatography is a technique that separates particles based on the rate of migration, on the stationary phase. Another concept, on the stationary phase. Yes, on the stationary phase. Now, in chromatography, we are trying to separate mixtures based on their different rate of migration or their rate at which they are going to be migrated in a particular phase called the stationary phase. Now, in chromatography technique, there are usually two phases used in separation. Now, use a simple reaction vessel. Now, there are two phases. Now, the first phase is the mobile phase, should be noted, and the second phase is the stationary phase. So, basically, there are two phases in chromatography during separation. So, the mobile phase and the stationary phase. Now, the mobile phase is the phase that elutes the solvent, or rather, is a phase that elutes the solute in the mixture. Now, for instance, now I want to separate a mixture using a chromatography technique. Let me quickly explain. Now, this is it. Now, for instance, I want to separate a mixture of A and B, two compounds, A and B, or A, B, and C, and a mixture. Now, how do you do this with chromatography? Now, first of all, we have an organic solvent. Now, the organic solvent is usually called the eluent. It might be a gas, and that gas is usually the mobile phase. Now, what happens is that basically, you have a solvent in the reaction vessel. Now, the solvent is going to, immediately you put your mixture, and the solvent is going to travel a distance. Let's say it travels a distance to this point on the stationary phase. So this phase that is not moving may be suspended. It's called the stationary phase. Yes, it's called. So the solvent moves. Remember, this was the solvent, the organic solvent. Immediately you put the mixture, the solvent travel a distance. So this distance traveled by the solvent is called the distance moved by the solvent. Now, as the solvent is traveling, remember these three things we added. Now, A can travel to this distance. Yes, A will travel to this distance on the stationary phase. B will travel to this distance, stationary phase. B will travel to this distance on the stationary phase, and the rest phase will be C. Now, so you see that the solvent helped them to travel on the stationary phase. So this the phase that helped to carry the solvent, or the phase in chromatography that helps to carry the solute you are about to separate, to be separated on the stationary phase, is called the mobile phase. So the mobile phase is usually of two types. So if you classify chromatography based on the mobile phase, you can have two types of chromatography based on mobile phase. Now, the two types of chromatography based on mobile phase can be liquid chromatography and can be gas chromatography. Okay, so based on mobile phase, you can have liquid chromatography, you can have gas chromatography. Now, based on the stationary phase, chromatography can be two types also. Two. Now, the two types can be partition chromatography, and adsorption chromatography. What is partition chromatography? Partition chromatography is a chromatography in which the stationary phase is liquid. Stationary, what's it called? When the stationary phase is solid, it is said to be adsorption chromatography. Adsorption. Now, there are various chromatography techniques, and they can be classified into any of these classes. They can be liquid chromatography, gas chromatography, based on the mobile phase, or partition or adsorption chromatography based on the stationary phase. So the various types of chromatography, which are paper, TLC, column chromatography, gas chromatography, HPLC, ion exchange chromatography, can be into any of these types of chromatography I've just talked about. So I'm going to use paper chromatography for this lesson, only paper. So during the subsequent lessons, we'll look at column chromatography, we'll look at gas chromatography, we'll look at HPLC, which is high performance liquid chromatography. So paper chromatography, briefly. Paper chromatography. Now, paper chromatography is used to identify compounds. It's used to identify compounds in a mixture, or it is used to separate compounds in a mixture. Now, what is the basic principle of the paper chromatography? Now, this is it. Now, in paper chromatography, usually, let's say we have a reaction vessel. Yes, it might not be this big, and make it smaller, or just for clarity, so let's make it this big. So I have a paper. Now I'm going to suspend the paper. Yes, I'm going to suspend the paper. Now look, this is it. Now quickly, for the paper chromatography, paper chromatography. Now paper. Now we're going to suspend the paper. Now this paper is usually cellulose paper, or many call it cellulose fiber paper, or they use cellulose filter paper. So the most popular paper is the cellulose paper. Now using the cellulose paper, now I'm going to use an organic solvent. Yes. The organic solvent may be polar, it may be non-polar, based on what you want to separate. So the organic solvent to be used is determined by the substances to be separated. Now let's say I want to separate a mixture of A and B. Yes, I have an organic solvent. I have an organic solvent on cellulose paper. And please, this cellulose paper, an organic solvent. I have an organic solvent on cellulose paper. And please, this cellulose paper has water. So there's water on the cellulose paper. Water on the cellulose paper. So the cellulose paper is wetted. Yes, it's wet. Now, water on the cellulose paper. Now, and the water on the cellulose paper is the stationary phase. So for paper chromatography, water on cellulose paper is stationary phase, while the organic solvent is the mobile phase. So we can call paper chromatography a liquid chromatography. So we call it a liquid chromatography. So how does it work? How does the principle work? Now quickly, once you put the mixture to be separated inside the solvent, A and B, inside the solvent, now quickly, so what happens is that the solvent travels a distance. It travels a distance. It travels a distance. So traveling a distance, you can travel a distance to this point. So it's only travel a distance to this point. Now note, the solvent was somewhere here before. It travels a distance to this point. So when it travels a distance to this point, this place the solvent came to is known as the solvent front. The initial position of the solvent to the solvent front is known as the distance moved by the solvent. So this is the distance moved by the solvent. This from here to here, distance moved by the solvent. Now, as the solvent is traveling, now A and B is going to be separated. Now this is it. How? Now let's say A is polar. Let's assume A is polar, B is non-polar. Now let's assume I'm using a solvent called ether. I'm using an ether in the solvent, a petroleum ether, which is the solvent is non-polar. Please take note. Solvent is non-polar. Ether solvent. So the solvent is non-polar. So quickly, if ether is non-polar, it means that B will be more soluble in ether than A. So how does this thing apply to chromatography? Now look at it. Now the separation on paper chromatography is based on two things. Now separation on paper chromatography can be based on two things. First one is solubility. Secondly is capillary action. Yes, capillary action in the sense that capillary action talks about the upward movement of a liquid and a material. So solubility. Now what's solubility? Now because A is not polar, A is less soluble in this ether. A is polar, pardon. A is less soluble in the ether. B is not polar, B is more soluble in the ether. It therefore means that B will travel with the solvent more. That means B will be strongly attached to the solvent and less attached to the stationary phase. It means that B is going to travel higher or more than A. That means A is going to travel less because it is less attached or less soluble in the solvent. A is less soluble in the solvent. So it will travel with the solvent down more. A is going to travel. So at the end of the day, we might create a band. or in paper chromatography, in most cases, we will observe them as spot. You see B as a spot, you see A as a spot. So such that from the so from the solvent, from the initial position of the solvent to B, or to the spot of B, if it's a spot, or if it's or to the spot of B, if it's a spot, or if it's a band, the spot of B is known as the distance moved by B. So this distance moved by B. While from the spot of A to the initial position of the solvent is known as the distance moved by A. So in paper chromatography, you can use one value. These values are called RF values. What does RF mean? Retention factor. So these values are very important when isolating organic compounds. So RF value is equal to distance moved by solute. So the solute is either A or B over distance moved by solvent. This is how to calculate RF value. An RF value is unique for given solvent and a given process. So every solute has their given RF value on their solvent. So RF value can be used. The RF value of many compounds are unique and are used to identify them when they are in mixtures of compounds. So solubility is the process. Solubility and capillary reactions are the process needed, or they are the basic principles we use to carry out separation of paper chromatography. Don't forget the polar solvent, the polar solute, A is more polar, A is more polar. Since A is more polar, A will dissolve less in the solvent, meaning A will not travel with the solvent that much, B will travel more. So if A does not attracted to the solvent, it therefore means that it will be attracted to the paper. So this relative solubility of A and B was used to separate them on paper chromatography. That's the basic concept of paper chromatography. So subsequently, look at column chromatography, TLC chromatography, and gas chromatography in our next video. I'll tell you subsequently that TLC is just like paper, same technique, same principle. So I'll see you guys